Suppose that x is a normal random variable that has a mean of 3 and a standard deviation of 2. Compute the probability that x takes a value greater than 1. Okay, so let's try and get a handle on what's going on here. X is normal. So it looks like a bell curve, the sort that we've drawn before. But we're told that the mean is 3. And the standard deviation, which sort of tells you how fat or wide the bell curve is, or how skinny and narrow it is 2. Okay, that's, without another one to compare to, I guess that's a good picture. And what do we want? We want the probability that x is greater than 1. So 1 would be about here, and it is greater than, right? Yes, greater than. So we're interested in x being a value bigger, so we shade to the right. So this is the idea here. But this is a normal random variable that we don't have a chart for. So what we're supposed to do is sort of rescale everything. You subtract everything by the mean of 3. Okay, and that'll shift everything over to be centered at 0. And what'll happen to 1? Well, it'll go down by 3 as well to -2. But you still get the same area. Okay. And then we rescale everything to make it sort of a little less fat, a little more peaked, or a little narrower. And as a result, everything shifts, and this -2 becomes a z-score. And so now we'll have the probability that our standard normal is bigger than some z-score. And that's a problem we already know how to solve. Okay? That's the thing with these normal random variables. You just reduce it to a problem you already know how to solve. Now, how do I figure out what this z is? Well, we've got a formula for that. Z is x, the value we're comparing to, minus mu over sigma. So we want the probability that x, our random variable, is bigger than 1. So the value we compare to is the little x. Okay, so this is 1 minus a mean of 3 divided by 2, which was our standard deviation. So that's -2 over 2, or z is -1. So the probability that x is bigger than 1 is the same as the probability that our z, our standard normal random variable, is bigger than -1. Okay, well that's a problem from the last sort of lesson. Okay, so what do? Well, we got our standard normal here. And we've got a negative z-score, and the area is shaded to the right. What do we do if you've got a negative z-score? You use symmetry. You flip the whole thing. That makes the z-score come over to this side and becomes positive. The area that was shaded to the right is now shaded to the left. So this probability that we want is the same as the probability that z is less than 1.00, and that is something we can look up in our chart. 1.0, and the hundredths digit is 0, so 0.8413. Oops, wrong one. So this is 0.8413. So to summarize, what happened? We had a probability that we wanted. We changed it to a probability in terms of the standard normal that we understand, and we changed that into a probability we could look up in the chart. And then that's exactly what we did. So 8413. So about 84% is the chance that x will give us a value greater than 1. And there's our answer.